Hi, everyone. So today we are going to focus on our 1.5, which is properties of real numbers. Our objectives in this section are being able to use both commutative and associative properties. Commutative is just the ability to move numbers around, and the results being exactly the same. So for example, if we have 5 plus 3, this is the same as 3 plus 5. 5 plus 3 is 8, and 3 plus 5 is also 8. So what have we just learned in this example? That commutative property works for the addition operation. And so you'll realize that both with addition and multiplication, commutative property works. Commutative property doesn't work when you are subtracting numbers or when you are dividing numbers. And then associative properties are the groupings of numbers or expressions. A good example of this is, for example, 3 plus 5 plus 6. This is the same as 3 plus 5 and then plus 6. All right, so we'll be seeing a lot of that during this section. We'll be able to learn about our identity, inverse, and our zero properties. And then our last objective is we'll be able to simplify expressions using our famous distributive property, which will pop up very, very often throughout this entire college algebra and trigonometry course. You'll see it almost all throughout your pre-calculus course, and then you'll also see it in calculus. Even if you end up getting a master's in mathematics, you will see these properties from a theoretical perspective as you are solving proofs. Very, very, very common. Okay, so I know this says example 2. It really should be example 1, but let's jump into this. We're asked to add these fractions together. And you'll notice that the first 2 fractions need to be added first because we have those parentheses. So how do we add fractions? We need to make sure we have a common denominator. What's the common denominator between 13 and 4? We're doing our nice, beautiful cake method off to the side. Because 13 and 4 are relatively prime to one another, all we have to do is take the product of both of these and we get our LCD, which is equal to 52. Now that we know our LCD, we need to manipulate these fractions into that equivalent fraction that has a denominator of 52. So what times 13 gives you 52? That's just 4. And what times 4 gives you 52? And that's just 13. So now when we multiply straight across our fancy forms of 1, we end up getting 20 plus 39 all over 52. And then we have this plus 1/4. And why don't we go ahead and put that in terms of a denominator of 52? So multiply this by simply 13 over 13. So we get a plus 13 over 52. Now that all the denominators are the same, we can just add the numerators. So we end up getting 20 plus 39, which is 59. And then 59 plus 13 is the same as 69 plus 13, which is just 72. So our final result is 72 over 52. But we can simplify this fraction. We can divide the top and bottom. Straight off the bat, we know that they're even numbers, so they're both divisible by 2, which means we're looking at 36 over 26. But 36 over 26 also has a factor of 2 that could be pulled out. So we're looking at 18 over 13, which is in simplified form as an improper fraction. But if we wanted to convert this to a mixed fraction, 13 goes into 18 one time, and then we have a remainder of 5. So either of these boxed answers would receive full credit. All right, let's move on. So we have a notes page, which is understanding our identity, inverse, and zero properties. And so an identity property, we have identity properties of addition and identity properties of multiplication. And so what does this mean? Well, from an addition perspective, is what can we add to a number that will give us that same exact number in the end. And so our identity property of addition is 0. If you add 0 to 5, you're going to get 5. If you add 0 to 1,568,000, you're going to get 1,568,000. So our identity property of addition is 0, and that's what we have represented generally here using that arbitrary value a, which represents a real number. Now, our identity property of multiplication is a way of saying, okay, what can we multiply by this random value to get our same random value again? So 6 times what number will give us 6? Oh, 1. So our identity property of multiplication will always be 1. 28 times 1 gives you 28. And then from the general standpoint, if we're using that arbitrary value a, we have a times 1 gives you a. Now, inverse property, what does that mean? The inverse, when we're dealing with addition, is just the opposite value that we're looking at. So the opposite number of 2 is -2. And so what we want to do is we have a number, and what are we adding? What's our inverse number that gets us 0 in the long run? Oh, it's just the opposite. -1 plus +1 gives you 0. +10 plus -10 gives you 0. And then from a general perspective, we have +a plus the opposite, -a gives you 0. Now, what's our inverse property of multiplication? Well, it's just the reciprocal of the number that we're looking at, and it will give us 1 every single time. So what is the multiplicative inverse of 12? It would be 1 over 12, because 12 times what number gives you 1? 12 times 1/12 gives you 1. What about -3? -3 times -1/3 gives you 1. And so from a general standpoint, we have a times 1 over a gives us 1. And obviously, it's important to mention that a can't be 0, because if a is 0, then we get that 1 over 0, which is an undefined value. And then finally, we have our properties of 0, and this just tells us, okay, what, from a multiplication perspective, what can we multiply by our arbitrary value to get 0? And so any number times 0 gives you 0. So the multiplication property of 0 is just 0. And then what about our division property of 0? What do we have here? Well, we know that whenever our numerator is 0, our fraction will always be 0. So 0 divided by any real number besides 0, because we can never have 0 in the denominator, will always yield us 0. So we ran through all the properties. Now let's give us some time to practice utilizing some concrete examples. Okay. So we have 3 terms here. And in this case, let's combine some like terms, but what do we notice? We notice some inverse values happening. The inverse of negative 84n is positive 84n. And what does that tell us? That cancels it out. So our final solution is just negative 73n. Instead of adding them left to right, look for patterns to make your life a little easier. What about example 4 here? Again, let's look for patterns. I have a positive 7 up here, a positive 7 down here. 7 divided by 7 is just 1. And then, oh, would you look at that? I have a positive 15 in the denominator, and the numerator, 15 divided by 15, is just 1. So what's our final result? 8 divided by 23, and we're done. Again, it makes our life much, much easier. Building up your number sense will save you a lot of stress, a lot of time, and put your mind at ease for the most part. All right, let's look at example 5. We have a part A and a part B. Part A is asking us to simplify 0 divided by n plus 5. Now, utilizing your zero property of addition, anytime you have 0 in the numerator, it is always going to be a 0 result as long as that denominator is not equal to 0. And what would make that denominator equal to 0 when n is equal to negative 5, which is why they put that condition in there. And then we have our part B, 10 minus 3p over 0. Well, we have that divided by 0. So that actually really doesn't help us at all. This is unsolvable, since we're looking at an undefined value from the start. Okay. So let's keep going. And finally, we're on our third objective, which is really having a strong understanding of our distributive property. And so again, when you're utilizing distributive property, you're distributing your outside term to each term within the parentheses, whether the term is on that left-hand side of the parentheses or the right, you are still distributing, whether it is positive or a negative operation sign, you are still distributing. It's just, are you multiplying by a negative number or a positive number? So let's put this into action. 3 times x gives you 3x. 3 times 4 gives you 12. So our final result is 3x plus 12. Let's do another example together. We have 8 times 3/8x, which is the same as 8 over 1 times 3x over 8. And you'll notice that the 8's cancel out. And then we have 8 times 1/4, separated by that plus sign. We have 8, again, as a fraction is 8 over 1 times 1/4. And 4 goes into 8 2 times. 4 goes into 4 once, so that can be simplified. So essentially what we're looking at is 3x plus 2. And that's our final result. Do another example together. Negative 11 times positive 4 is negative 44. Negative 11 times a negative 3a. Negative times a negative is a positive, so we have positive 33a. And we're done. So we're getting pretty good with distributive property. Then we have a little notes page. So there'll be times when we'll need to use distributive property as part of the order of operations. And we start this by looking at parentheses. We look at the groupings. If the expression inside the parentheses cannot be simplified, then the next step would be multiplying using that distributive property, which removes those parentheses. Okay, so let's tackle example 9 together. Again, we have some distributive property. We have 8 minus 2x minus 6. Combine some like terms. And we're looking at 8 minus 6, which is 2, minus 2x. Second example, 6x minus 54 minus x minus 12. Combine some like terms. We have 6x minus x gives you 5x. And then you have minus 54 minus 12 gives you minus 66. And then we're done. Okay. So this completes our section 1.5, the end of chapter 1. Let me know if you have any questions, and I hope that this was helpful. Take care.